back with a new topic, which is glass and its various types. Glass is a complete mixture of several silicates. All glass contains silica. Common soda glass contains sodium and calcium silicate and has the approximate composition Na2O, CaO, 5SiO2. In addition to or in place of soda and lime, a special glasses may contain potash, bratra, magnesia, lead oxide, and zinc oxide. They may also sometimes contain borate and phosphates. The properties of glass are profoundly modified by its composition and hence based on composition can be classified into soft glass. Contains sodium and calcium silicate. It is used for general purpose glasswares, flat or hollowware. Lead crystal glass or flint glass. It contains potassium and lead silicates and has high density and refractive indexes. Hence, it is used in making lens prism. It is also used for decorative purposes as cut glass. It is very expensive and used mainly for bowls, drinking glasses, vases, etc., which are not in constant use. In flint glass, very soft lead is used in the form of litharge, PHO, and red lead, PH3O4. Borosilicate glass, Gina glass, and the Pyrex glass. They are highly resistant to the action of heat and chemical reagents and are used to make baking dishes. The Gina glass contains zinc and barium oxides and boron trioxides in place of some silica. In Pyrex glasses contains boron trioxide and is very rich in silica. It contains sodium and aluminum borosilicates. Flat glass. This is made from soda lime glass and is used for windows, shells, etc. The flat glass are of two major types, sheet glass and the float glass. The sheet glass is drawn continuously from the matter mass and passed through the annealing tar, after which it can be cut into the required lengths. The float glass. It is like plate glass in many instances, but unlike plate glasses, it does not need to be ground and polished after annealing. Both are made from very fine ingredients and provide clear, undistorted vision and are used for for the shop windows, mirrors, and protective coverings on furnitures. The edges are often leveled, that is, cut at an angle, while those on shelves are ground and corners rounded. Silvered glass. They are used for mirrors. It is made by coating one side of the glass panel with silver and some case copper, followed by a coat of paint and a layer of stove enamel. Silvered glass may be used for tiles or mosaic as a reflective sheets. Laminated safety glasses. Much used in automobiles. It is made by enameling together two sheets of thin plate glass with a layer of non-brittle plastic material, that is, a transparent cellulose acetate or polyvinyl butyl in between. When glass breaks under impact, the fragments are held in place by the flexible inner layer. Fiber glasses. Glass is reduced to flexible filament or threads. It is an excellent heat insulator. Fiberglass is woven into fabric for fireproof curtains. Glass is also spun into short fibers known as glass wool. The colored glasses. It is made by adding various metallic oxides which yield colored silicates and other substances to the molten glass in course of its manufacturing. On the screen you can see the various color of glasses and the coloring agents used for the same. Manufacturing. The ordinary glass is made by a fusion of a mixture of glass, glass sand, soda ash, and limestone, SiO2, Na2O, and CaO. Silica is the glass former, soda acts as flux, and lime is the stabilizer, conferring durability to the glass. In addition, small quantities of sodium sulfate, sodium nitrate, fluorspar, arsenic oxide, etc. are added to act as the melting refining aids, as glass in molten state is a viscous liquid. It entraps bubbles, CO2, SO2, steam, etc. Removal of these bubbles is called refining. Iron oxide is the major impurity that enters into glass through raw materials and imparts unwanted color to the glass. The glass furnace is a rectangular chamber lined with superior quality reflective blocks that can withstand high temperature, about 1600 degrees centigrade. It has two chambers, one for melting and refining, and other for working where homogenized molten glass is withdrawn. A constant level of molten glass is maintained by introducing raw materials at one end and withdrawal of molten glass at other end. Somewhat colder molten glass is drawn from the working chamber and shaped into articles manually or by machines. After shaping, the glass article has to be cooled very carefully. This process is called annealing. Glass that is cooled rapidly is brittle due to the existence of internal strain and is liable to crack on heating or receiving slight shocks or scratches. If cooled too slowly, the glass de-interferes. That is, some of the component starts to crystallize out separately, rendering the glass opaque. All glassware is therefore annealed to reduce the internal strain by heating for some time at a temperature just below the softening point of the glass for around 500 degrees centigrade, so that the articles do not get deformed. Then they are slowly and uniformly cooled, annealing over in a tunnel like furnace, hot at once and provided with a slowly moving frame holding the glassware. This might sometime take days. Various types of glasses. First is the obscured and safety glass. Both are made from the sheet or flat glass. Obscured glass is required for bathrooms and other places where light requires passing without it being transparent, often having a pattern on one side. This is produced by passing molten glass between embossed rollers. Safety glass may be embossed glasses with wire. Wire is incorporated during the rolling process. Wire prevents glass fragments from falling when broken. Laminated glass, made by sticking two thin sheets of glass with a vinyl type plastic in between. Toughened glass. It is made by subjecting the glass to a temperature just below the softening point and then cooling the surface layer rapidly. This forms a skin on top of the glass, and if broken, the glass shatters into small, harmless fragments. Toughened and laminated glasses. This is 5 times stronger than any other types of safety glasses. Enamels. Enamels are fusible glass rendered opaque by pacifiers like tin oxide, titanium oxide, and zirconium oxide, which are applied cold and fused to the metal surface at red heat. The raw material for the enamel glass includes quartz, feldspar, and fluxes, borax, and soda ash. Enameling of iron or brass ware prevents atmospheric corrosion. Enameled wares are in large demand as sanitary and cooking ware, nameplates, signboards, refrigerators, and dairy equipments, etc. Glaze. Glaze is a thin coating of easily fusible glass molded onto the surface of the more or less porous ceramic ware. The glaze composition includes refractory ingredients feldspar, silica, china clay, and lime, and fluxes, soda, potash, borax, lead oxide in different proportions. Now, let's talk about maintaining the glass surfaces. Daily care involves damp and dry dusting, preferably with lint free cloth such as paper or scrim. High soiling and greasy finger marks can be removed by wiping with a solution of equal quantities of vinegar and water or a mixture of 100 ml ammonia to half bucket of warm water. Most stubborn marks such as makeup and toothpaste deposits found in mirror can be removed by wiping with a solvent such as methylated spirits. Newspaper prints contain solvent and can be used to clean the windows pane and mirrors. Textured or engraved glass should be cleaned occasionally with a very soft brush. The use of abrasive should be avoided. Thank you.